two-point form of equation of a line. What I'm trying to stress here is that look how easy it becomes once you just have a grasp of just the most common one, which is slope-intercept form. So we again start from slope-intercept form, but before that we need to see these things. 2 points. 2 points would be given to us. So let's take our 2 points. Let the 2 points be P1 and P2. The coordinate of P1, let it be x1, y1, and let P2 be x2, y2, right? So it just starts from the same way. We first take the slope intercept form, the one which we are most familiar with. The slope intercept form gives us y equal to mx plus c. So we substitute P1, okay, P1, because P1 lies on the line. P1 lies on the line, right? And substitute P1's means the coordinate of P1 must satisfy the above equation. So if you substitute, it would be y1 equal to m of x1 plus c. We get the value of c as y1 minus mx1, and then what we do is we take this value of c and we again substitute it here. So our original equation now transforms from slope intercept form to point slope form, and it would be given by y equal to mx1 plus y1 minus mx1, and transforming y minus y1 is m of x minus x1. Now what we do after this is, we repeat the same procedure with P2, because P2 also lies on the line. So we take y equal to mx plus c, and after repeating the same procedure, we will now arrive at y minus y2 is equal to m x minus x2. So what we do from both this equation is we try to take the value of m, y minus y1 divided by x minus x1. And if we look from here, it would be m is equal to y minus y2 divided by x minus x2. Now comparing this expression with this expression, both the expressions talk about the same thing, that's the slope of the same line. So if we compare them, we can say that their left hand sides are equal to their left hand sides for a and b, and so right hand sides must be equal to the right hand side. So let's just equate the right hand sides. So we would say y minus y2 by x minus x2 is equal to y minus y1 by x minus x1. Simplifying it further, we write, let's use a different color now. So it's y minus y2 upon y minus y1 is equal to x minus x2 upon x minus x1. So that's my 2-point form of equation of a straight line, where 2 points P1 and P2 are given to me with coordinates x1, y1 and x2, y2. Now since we have found the 2-point form of equation of a straight line by the analytical method, the most interesting part would be see how easy it becomes once you have an understanding of slope. Okay, let's see how quickly we can actually deduce this equation if we follow the graphical method. Okay, so we have a Cartesian coordinate system. Let me plot my Cartesian coordinate system. So, right, this is my Cartesian coordinate system, and let me take a line out here. Sorry, let me take a line. Say this is my line. So this is 2-point form. So let me take 2 points on this line. Okay, let this be 1 point. Let this be 1 point, and let this be the other point. Okay, and let me name these points. I call this point as P1, and I call this point as P2. And let us trace the coordinates of these points. So this is P2 and this is P1. So P2 is x2, y2, which means this is y2, this is x2, and P1 is x1, y1, right? I would also complete one imaginary triangle, say this being. Now let us take a point xy. I call it as my tester point. Xy lies on this line. So because we will be forming an equation, so we need one more point. So let this be our tester point, and let the coordinates of this point be x and y. This is an arbitrary point which lies on this line. Okay, so let this be x and let this be y. So if you see, we have got 3 points, P1 and P2 are the 2 points given, and P is a point which is xy. Now since this is a line, the slope of the line is constant throughout, right? So let's try to find out slope of P1P. Okay, slope of P1P. So that would be given by rise over run, rise over run. So let's see, what is the rise? The rise would be y minus y1, and what is the run? The run is x minus x1. Let's find out the slope of P2, okay, P2, which will also be equal to rise over run, and if we complete it right out here, so P2 will be y2 minus y divided by x2 minus x. Now if I term them as A and B, they are the slope of the same line, so A should be equal to B. So let me equate A and B. So if I equate A and B, I get y minus y1 upon x minus x1 is equal to y2 minus y upon x2 minus x. If I compare this with the format of equation that we had found out, so we'll just do a little bit of rearrangement out here. So y minus y1 upon y2 minus y is equal to x minus x1 upon x2 minus x. Now let me clone this equation which we had reduced analytically and bring it on the screen so that we can have a comparison of both. So if we now look at it, it's y minus y2. So let's invert this equation which we have deduced. So it becomes y2 minus y upon y minus y1 equals to x2 minus x divided by x minus x1. If you invert the numerators, it becomes y minus y2. So obviously minus 1 will come out as common from here. So y minus y1 is equal to x minus x2. So a minus 1 comes out from here, x minus x1, and cancelling the minus 1 on both sides, we will have the required equation which we had solved analytically, and both will look the same. So it becomes y minus y2 upon y minus y1 is equal to x minus x2 upon x minus x1. So if the concept is clear about slope, no matter the way you proceed, you're going to get the same answer. So hope by now you've got a fair bit of idea about how to compute slope and how to employ the learnings of slope to deduce various forms of equation of a straight line.